Greetings, this is Artie from Artifact Electronics. In today's episode we're going to look at this scope, and there's a bit of a backstory here. I went to my repository of electronics in need of repair, and to my horror it had shrunk down to almost nothing. However, the nice thing was, I said almost nothing. This is what was left in the pile, and I'm actually looking forward to seeing what we can do with this. This is a Tektronix 465M 100 meg dual trace purely analog scope from the late 70s. This one was built specifically for the US Army, as you can see in the tag on top, and I'm sure this and many of its brothers did double duty to keep us all safe during the Cold War. But as with everything else, they've seen their service and have been superseded by more useful instruments. Even though it is an analog instrument, and my personal opinion is that pure analog scopes, at least in the near future, will never be fully replaced by digital scopes with LCD screens. So let's see if we can, I don't remember when I've had this for a while. I don't remember where it came from and what state it was in. So let's go ahead and fire it up and see what it does. There's a change of plans. Things didn't go as I expected them to go. The scope was not very cooperative. It came on, and one of the really nice things about this, other than being pure analog, is it doesn't have a fan. It is completely quiet. But that was about all that was good about it, because it took me quite some time. Initially, I couldn't even get a trace up, and I wasn't even sure if the screen, if it was the screen being inoperable or what it was. But pushing the beam finder button over here put two unfocused splotches on the screen. I could not properly focus them, and so I tried everything that made sense, and I could not get a trace. So I just started turning buttons and pushing buttons and changing settings and everything. And the best I could do was I got a partial trace for channel 1 that spanned about 1/2 of the screen and sat in approximate middle of the screen. Was really fuzzy, could not be focused. So I'm not going to show that footage because it was quite discouraging and unproductive. So yes, we do need to take this guy apart, and probably a good place is to first do a visual inspection of the guts, and then start checking the power supply voltages. So let's go ahead and do that. So I get started testing the low voltages, and most of them were in good shape. Ripples were within specs. One thing to point out, for instance, it uses unregulated voltages in certain places, and one thing that gave me where I thought I had found the problem was one connection point said 32 volts unregulated, and it read 50 volts, but looking at the schematics, that's actually correct. So whenever you see a voltage feeding something and it says unregulated, it's most likely going to be significantly higher than the rated voltage at that point. But that's pretty normal. However, I did find that there is a 95 volt supply that is the reference supply for the CRT, and that showed 89.4 volts, which is more than 5% lower than the rating. And I measured it with a meter. I also measured the ripple, and the ripple was around 2 volts on the meter. So that immediately rang the bell. Capacitors. Well, it took me a while to go through the schematics, and as you can see, they're not of excellent quality, but infinitely better than not having any. And it took me a while to find where the 95 volts was being generated, and it's right here. It's on the interface board, which is basically the motherboard, the bottom board that connects everything together and does a lot of things aside from that. And so what it does is it takes the unregulated 32, and it also has an oscillator over here, and it generates all of the high voltages further up here, but the 95 volts comes out of here, and essentially there's a half-wave rectifier here, followed by 2 caps, an inductor, and a protection diode over here, but that's the 95 volts. So of course I checked the diode first, and it measured good even in circuit. And then I measured this capacitor here, which is a 2.2 microfarad rated at 200 volts. And I got some very strange readings out of that. So I removed it, and I'll show you what it looked like out of circuit. So here's the cap, and it looked like that it had some slight leakage underneath. There wasn't anything on the board, and first I thought maybe it had been glued down, but it wasn't glue. It kind of wiped off. So something was amiss with this guy. And when I measured him, so this is supposed to be 2.2 mics, and the ESR meter says 0.6, but the ESR, it can't even read that high, and it just says it's greater than 40 ohms. So this has turned into a resistor mostly. And an interesting thing to note is that when I tested it with a fluke meter, the fluke meter actually read it at 2.4 microfarads. But you know, whom do I trust, the fluke meter or Mr. Peak? I'm going to trust Mr. Peak on this and declare this guy to be dead. Of course, I don't have a replacement right now, and I don't really look forward to waiting several days on this. So what I did find, though, is, I guess I lied, I do have a replacement. And the replacement right here, it's an unpolarized, rated at 250 volts DC, 2.2 microfarads. Problem with it is, as you can see immediately, its physical, its size is going to pose some problems as compared to the original, especially since that's sitting in the high voltage cage, so there's only limited space. But I'm sure we can figure out a way to fit it in. But first, let's see what this one reads at before putting it into the circuit. And it is right on. It is right on. And because it's not an electrolytic, it has really low ESR. So this is actually a much better part than the other one. So let's turn our attention to the physical part of this exercise. So disassembly and module removal is rather well documented in the service manual. and at first, or at least it seemed that way at first, the case itself came off, and in order to gain access to the capacitor in question, I had to get to the high voltage cage, which is sitting down here, and this cover comes right off, but they tell you that in order to get there, well, I had to take the bottom of the instrument off in order to be able to desolder the component in question, and you can kind of, here's the bottom of the unit. So the first problem arose when it basically said, well, take off the back, and that worked just like the instructions said. Remove a few screws and carefully remove the back, and there's a bunch of connectors like this threaded through, and you follow the instructions and you won't rip out anything and you'll get the back off. However, to get the bottom off, it told me to remove a certain number of screws. So I had to remove n screws, and n-1 screws removed very easily. But the nth screw was inaccessible. It was basically covered by a shaft coupling of one of the pots running through. And I'm not sure if I can show you this, but for those of you disassembling it, don't scratch your heads too much. There's a screw down in here, and I mean, if you look very closely, let's see if I can make that more visible. Right in here, there's a screw under the shaft coupling here. And the shaft coupling completely obscures, it obscures the screw. You can't get into it. And that screw needs to be removed in order for the bottom to come off. So at this point, the manual was not very true anymore to what needed to be done. And the solution to that was to basically, the vertical board, which is this assembly over here, and is actually only held in place by a single captive screw over here. So you loosen the captive screw and the whole thing slides out. Now they do caution you to be careful of the deflection wires over here, the two white wires you can see. And I didn't pay full attention, and as I was removing the board, which has like an edge connector on the bottom, it came out all at once. And ripping out these two wires, and it ripped them out from the actual connection to the CRT. So for a minute there I thought, I'm done for, but fortunately it wasn't so. It broke. There are two solder joints here which you can't really see at this angle, but the solder joints had broken off, and it was relatively easy to solder the wires back in again. But of course this allowed me to pull out this board, gain access to the last screw in there, unscrew it, and get the bottom off. There are some other gotchas with this. These wires, these white wires, are very short, and they connect to this board underneath this bunch of wires over here. And it's a pretty delicate act getting these wires plugged back into the board. Let me just warn you, I don't have a true and tried method. You just have to sweat it out. And what I actually ended up doing was loosening these screws so this whole assembly would slide up, and sticking a pair of pliers underneath and just finagling the two wires to go back in. But be careful when you're removing this board, and be very vigilant when reconnecting these wires to where they belong. And with all of that said, I finally had access to the bottom of the board, and let's see if I can show you a view of where the offending capacitor sat, and that was, where are you? See those two holes? I mean, you can't see the holes really, but you can see light shining through right here. That's where that capacitor sat, and since I had the bottom off, of course, it was very easy to desolder it. But you can also see that the replacement that I am planning on using is going to be a little bit difficult to insert in there. And if I find it, just to give you a size example, so we basically got to fit this into there without shorting against the cage support. It's surrounded by metal everywhere, and of course there's also the top of the cage, which is also metal. So we got to make sure that it is not shorting against any of the metal surrounding it, and even more important than that, any of the transformer leads coming out of there. So let me go ahead and see what I can do. I'm not going to attempt to film it because you're not going to be able to see anything while my fingers are stuck in here, and I get discombobulated about having to put this capacitor in there. Okay, the deed is done. Took me a while to get it in there, but it finally fit. It's got clearance on all sides. It's got clearance on the top. It is kind of sitting on top of the rectifying diode, but there's space in between it, the capacitor, and the rectifying diode right underneath here. So everything's okay. The only thing I was a bit worried about was the back end over here, and that I put some heat shrink tubing on the capacitor lead here and made sure that it's, that there's at least some distance between it and the metal over here. And I mean, it is 95 volts, but I don't think that's high enough for us to run into any danger of arcing with the exposed leads running underneath. But I guess I'll find out soon enough. But yeah, I don't think that's going to be a problem. So let me go ahead and put the cage back together, make sure that everything is plugged in, and give this guy a tryout. Well, I didn't actually put it back together, but I made sure that nothing was shorting, that everything essential was connected, and it would have probably been a bit premature to connect it already or reassemble it. So let's see first what it does right now with the new cap. Well, it thinks it's triggering, and we got two traces. Very nice. Let's see if we can improve the focus. Well, doesn't look too bad. So let's turn on Mr. Noisy here and put an actual signal in here. I'm not going to tax it too much. What I'll select, I'm going to select 500 kHz signal, and there you go. Nice and sharp. The time base works. It's beginning to look a little exponential there, but at least that part works. And the variable amplitude works. So that actually looks pretty nice. Scale illumination. And switching waveforms. And a square. And I'm playing with the trigger level, but a square wave isn't exactly the best thing to demonstrate that. So let's go back to the triangle, and now we should be able to see the trigger level work. It's actually a really nice display, and all hail to analog scopes, especially the ones that work. So now I'm going to put it back together for real, and then we'll have a final look and see if everything else is okay. Now, one other thing I did before I showed you this was the pots were pretty dirty on this. Changing vertical or horizontal positions made it jump around wildly. Changing intensity, was none of that worked very smoothly. It worked, but not smoothly. So, of course, like most Tektronix scopes, this one has sealed pots. And we know that this is being caused by dirty pots, so what to do? And one of the best things to do is I set the scope back on its hind legs so that the screen was pointing up. I then covered the surroundings of all pot bodies with paper towels in anticipation of spraying it with a contact cleaner. And I usually do that because I don't want contact cleaner to get all over the place. So the scope was sitting screen up, so all the pot shafts were pointing up, and the back end of them were covered in paper towels. And then, of course, I brought in the contact cleaner. And one thing to be careful of is you need to modulate your pressure very carefully on the spray can, because you don't want to give it a full spray and get it all over the place, but just enough so some liquid trickles out of the spray nozzle. And you want to do that onto the shafts where they enter the pot bodies. Since the shafts are pointing upward, once we get the liquid on there, we let it sit for a while and let gravity do its work, so as for the contact cleaner to flow into the pot. And then we turn the pots several times to clean and distribute the contact cleaner. And in this case it worked rather well. As you could see before, that the adjustments worked. Let's see, where is the position adjustment? That one I haven't tried, but that one's working smoothly too. So it looks like we're good to go. So, as said before, let's go and actually put it back together. Here we are, everything's reassembled, some more cleanup, Another thing I found while I was putting things together again is that some of the rotary switches seem to have been dirty too. Now they caution you inside to use only IPA to clean it. So wherever I could, I sprayed some IPA into the contacts and just worked the controls a bit. And that did a pretty good job of cleaning up the problems. So one last thing I wanted to do is talk about the delayed sweep, because with the emergence of all of our digital scopes and stuff like that, to me personally it was a bit unclear what exactly the delayed sweep meant, and I've come up with a very simple, maybe non-realistic but simple example that made me understand it. And if you ever wondered about what that means, then maybe I can shed some light on your questions. The delayed sweep is a means to observe parts of a stable waveform you have, i.e. zoom in on certain parts of them and see what's going on in there, because the portion that you're usually interested in can't be displayed on its own, or is very difficult to display as a stable display. So you just pick a larger sample, get it to display, and then zoom in. So the hardest part, of course, is getting that waveform, but I'm going to cheat and use the scope's compensation output. And this is shown using the A time base. And let's say this is our waveform, and we want to observe or go into detail and see what's going on in there. So the way to do that is on this scope, we go to the A intensified, and what that means is it's showing us the portion of the waveform that we want to see in detail. Now over here it still doesn't make a whole lot of sense, because the portion is it's a very large portion that it's looking at, but the reason for that is that we haven't changed the time base for the detail we want to see. And the way we do it on this scope is we pull this knob and change the time base. So now it shows us a small portion of the waveform, and it's basically an indicator that tells us which part of the waveform we're going to be able to observe in detail. For that we go into the B mode, and what it is showing us now is the part of the waveform that was highlighted in the previous display. And we can thus step through the entire waveform, which of course is a bit boring here because it's just a square wave, but imagine that you have a more complex wave, and this will let you move the detail window, slide it across the original waveform. Again, back to here to illustrate, as we're turning this knob, it is just changing which window it's showing. And again, we can change the time base and make the detail even more higher res. So when we go in, now this is what we see. And another neat feature this has is the combined or the mixed mode. And what that does is it shows you, as you're moving the window, it shows you the original waveform on the left side of the screen, which morphs into the detail waveform. And again, as you change the delay, that moves further along. It slides the window further along the entire waveform. So if we go back to look at the whole thing again, and we can change, maybe we want to see a little bit more detail, we'll change the B time base, which is the detail part, and looking at the mixed view, you can see that we can now again scroll through the entire wave, But in this case, as a reference, we see what the original waveform looks like, and we can change the point at which it starts showing us the detail. Probably with today's machines, not a very useful feature, but I think it's still worthwhile knowing what this does. At least for me it was, because I was never quite sure exactly. I mean, I knew how it worked. I knew how to invoke it, but until doing it this way, quite frankly, I couldn't see the usefulness of it. But putting it in this context, where you can basically look at details of a waveform, and those details by themselves can't be shown as a stable waveform, this makes sense and was probably a very useful feature when this unit was state-of-the-art. So with that, we've come to the end. Thanks for watching, and I hope you enjoyed watching it and maybe even learned something. So please give the appropriate thumbs up and subscribe if you haven't already done so. And we will see you in the next episode.